Hi again, guys. How are you? So this is the last talk from Friday, the final day from Porto Tech Cup conference. So let's keep till the end, guys. I know that we've been here for 4 hours already, but we have Rob Richardson with us that will speak about JavaScript and, of course, the grubby parts of JavaScript. I'm pretty sure that you are all already trying to figure out what are that parts. Rob, are you ready?
I am.
Thank you very much for joining us, and thank you very much. It is a pleasure to end this cycle of talks with you, such such an important person that studies this language of programming. So thank you very much. And the floor is yours, Rob.
Thanks. I'm so excited to get to join you here in Porto. It's fun to be able to share JavaScript with you. We're going to dig into some of the intricate parts of JavaScript, some of the weird bits, and see if we can start to understand why they are so weird. And maybe that'll help us to be able to make them a little bit less weird. Here's the part where I tell you I am definitely going to post the slides on my site tonight. I've been that person chasing the speaker, and it hasn't worked out very well for me either, which is why you can head to robrich.org right now. And let's go there. We'll click on presentations here at the top. And here's JavaScript, the grumpy parts. The slides are online right now. While we're here at robrich.org, let's click on About Me, and we'll see some of the things that I've done recently. I'm a Cyril developer advocate. If you're struggling with your data mesh, I would love to learn from you. I'm a Microsoft MVP, a Docker captain, and a friend of Redgate. AZ GiveCamp is really fun. AZ GiveCamp brings volunteer developers together with charities to build free software. We start building software Friday after work. Sunday afternoon, we deliver the completed software to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ GiveCamp. Or if you'd like a GiveCamp here in Porto, or wherever you're connecting from, hit me up on email or Twitter, and let's get a GiveCamp in your neighborhood too. Some of the other things that I've done, I worked as a core contributor on the Gulp team in version 2 and version 3. That was a lot of fun. And my claim to fame, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame, my coveted .NET Rocks mug. So let's dig into JavaScript, the grumpy parts. We talked about this guy. I want to say a big thank you to Jonathan Mills. John does a talk called A Guide to JavaScript Scary Side, and he and I started talking after that talk, and this talk grew out of that. So thank you to John for making this possible. If you have a chance to see John Mills speak, he is amazing. I'm excited because we're probably going to get to the edge of my knowledge. And so as your questions get into interesting things, may come a time where I say, I don't know. And I'm looking forward to that. I'm looking forward to this being a conversation for me to be able to learn from you too. So in the beginning, how did JavaScript come to be? Here's Brendan Eich. Brendan Eich wrote JavaScript in 10 days, 25 years ago. If you want to learn more, grab these slides from robrich.org, and you can click these blue links to either read more or watch more to learn more about Brendan Eich and his process of building JavaScript. Now, he built JavaScript in 10 days, and after a time, he was like, you know, there's some bugs here. I'd love to be able to come back and fix them. And he was told, there are 40 developers already building content in this language, and we can't break their content, so you'll just need to leave the bugs in. I bet there are 40 people here today that wish he had gone back through and fixed some of the bugs. Yeah, but I look at the code that I wrote 25 years ago, and it's pretty awful. Nobody's talking about it anymore. I'm not even talking about it. And yet Brendan Eich's 10-day experiment 25 years ago is the way that the web works. That's really amazing. Kudos to Brendan Eich. Brendan Eich created JavaScript, and JavaScript has been cloned into lots of different runtimes. In V8, we have the V8 engine in Chrome and Node, now in the new Edge. We also have SpiderMonkey in Firefox. We have the Chakra engine for the old Internet Explorer browser, and we have JavaScript Core in Safari. Now, all of these engines will run JavaScript JavaScript has been cloned with amazing precision and fidelity. When they went to clone the JavaScript engine into each of these browsers, they copied it, including all of the bugs. Now, when we talk about differences in browsers, we're often faced with mechanisms where browsers will behave differently in different scenarios. It got a lot better with HTML5. But usually the difference here is not the JavaScript engine, but rather JavaScript's interface to the DOM, the document object model. Browsers render the DOM very differently. And so a lot of the weirdness that happened in JavaScript wasn't in the JavaScript runtime itself, but rather in the DOM. So JavaScript itself, including all the bugs, is really consistent in lots of places. The methodology of JavaScript. JavaScript was designed to run over there once the developer had left. Unlike other platforms, with JavaScript, we download our source code and the browser runs it. Now with Webpack and Babel, we may have pre-compiler type of experiences, but we're still downloading JavaScript to the browser. We're not compiling a content, linking all of the resources, and sending an executable down to the browser. We're sending our source code. And so the browser is a runtime environment that is memory constrained, where the developer has probably already left. So JavaScript's primary methodology is to keep running at all costs. Can it autocorrect things? Can it fix things? That's the JavaScript methodology. And so, for example, we talk about semicolons. Are semicolons required in JavaScript? Well, they are required in JavaScript, but the JavaScript runtime engine is really good at compensating when we leave them off. If JavaScript gets to a syntax error, it's going to back up and see if it can insert a semicolon to be able to make that program run correctly. And if we leave off all the semicolons, that's exactly what it does. It puts in all the semicolons, and then our program runs. That methodology of trying to keep running at all costs is going to be a really good methodology for how we understand some of the weird parts about JavaScript. It is a runtime where the developer has left, and the runtime needs to keep running. So let's look at some of the weird bits. This is, as you grab these slides from robrich.org, I would encourage you to push play here. The JavaScript WAT talk is really amazing. And what's really elegant about this one is this is Brendan Eich playing the JavaScript WAT talk at a conference, a Fluent Conf. And he stops the video from time to time offering commentary. It is amazing. Now, the WAT talk highlights a lot of weird places, but doesn't really explain why. But it is kind of interesting. Let's look at some of them. Undefined. In JavaScript, undefined is just a variable, and you can define it. Well, in modern versions of JavaScript, it's actually a constant, so you can't redefine it. But it was a great way that we control our programs by, defining undefined, because it was just a variable. Type of null. Type of null is an object. Why is it an object? Why isn't it, null or undefined? I suspect this is probably one of those bugs that Brendan Eich wanted to fix and couldn't. Null is, well, a thing. And so type of null, I guess it kind of makes sense that it's an object. This one makes a lot more sense. Type of not a number. Type of nan. Now, nan, the type is a number. Now that kind of doesn't make sense because its definition is not a number. But if we kind of think through the different variable types in JavaScript, we have Booleans, we have numbers, we have strings, we have objects, we have arrays, we have functions. Of all of those groups, it kind of fits into the number group more so than anything else. So I guess it makes sense a little why not a number is of type number. It's more a number than, say, a string or a date. But yeah, that is kind of weird. Now, the weird bits are kind of weird if we don't think about it more deeply, but let's peel back the onion and see if we can understand how it works. Let's take a look at the JavaScript compiler. Now, the JavaScript compiler is a two-pass compiler. In the first pass, we go look for variables and we allocate the memory for those variables. In the second pass, we go execute all of the code. If you want to learn more, grab these slides from robrich.org, and you can click on each of these blue links to read or watch more about the JavaScript compiler. Now, the cool part about the compiler is it definitely has been optimized in modern engines to do just-in-time compilation and tree shaking and recompiling hot paths. And we're going to set all of that aside for now and just talk about that two-phase compiler. Now, because it is this two-phase compiler, it's going to have some interesting quirks and features. The first phase, reading the code. The second phase, executing the code. So let's take a look at an example here. Now, in this example, our first pass is going to be looking for variables to define. Well, we have this variable right here, this foo variable, so we're going to allocate memory for that. In our second pass, we'll go execute the code. We'll start out by defining a main function, then we'll execute a main function, and then we'll console log our foo variable. Well, when we go looking for a foo variable, we define this foo variable here in our first pass, and we haven't set a value to it yet. So when we console log, the value is undefined. In JavaScript, variables are defined with function level scope, not curly brace level scope. So this foo variable is in the current scope. Inside this true block, we will set its value to bar. And then as we leave this curly brace, now we'll console log the value again. What was undefined is now set to bar, so we'll console log bar. Now that's interesting. We kind of got to think through it with that two-pass compiler to be able to understand why we could log undefined rather than missing variable here. Now, pardon me. A good way to think of it is variable hoisting. Now we can kind of imagine that this variable got hoisted to the top here, and now it's set to undefined, and we can kind of think of it that way. And that helps us kind of reason about this code. Now, technically, it didn't get hoisted. It was the two-pass compiler that made that process happen that way. Hoisting is a convenient lie, and it helps us understand our code a little bit better, maybe. But it is a trick that we tell ourselves. Hoisting, it's a lie. Hoisting is actually the two-pass compiler. We look for variables and we allocate them. And then in the next pass, we execute them. Now, it is a convenient lie, and it may help us reason about our code without having to understand the two-pass compiler. But that's that mechanism. Because we have a two-pass compiler, then we end up with what we'll conveniently term variable hoisting. Let's take a look at a bunch of examples and see if we can think like the compiler to understand what's happening. We looked at this example previously. What happens in this case? Let's think like the compiler and see if we can figure it out. Our first pass is to go find variables to allocate. We have one right here, so let's allocate this variable. Next, in our second pass, we will execute the code. We'll define a function, and then we'll execute it. Inside of our function, we will look for variables. We found one in the current scope because our variables are defined with function level scope. And so we'll log undefined. Then we'll set its value to bar, and we'll console log bar. Let's take a look at lots of different examples where we can define and not define variables inside of JavaScript to yield interesting results. So here I have defined two different foo variables. We'll call this maybe an outer foo and an inner foo, or foo1 and foo2. What happens in this case? Think through and see if you can identify how this code will play out. Now let's think like the compiler and see if we can solve it. In our first pass, our goal is to find all of the variables that get defined. So we find our outer foo and we find our inner foo. We've now got those two variables allocated. In our next phase, our goal is to execute the code. So we'll set our outer foo to bar. We'll define a function and then execute it. Inside of our bar function, we have this inner foo variable, and we'll set it to baz. We now have these two variables. One is set to bar, one to baz. Inside this true block, we will set foo equal to bam. So we go looking for this foo variable in the current scope. We find one right here. So what was Baz is now Bam. We'll console log Bam. Leaving the curly brace, the blocks are defined as function scoped. So we're still dealing with this foo variable right here. And so we'll console log Bam again. Leaving the function, we will console log a foo variable. We go looking for a foo variable in this scope. The function's foo variable has already disappeared. So we'll find this foo variable here. So we'll console log bar. Bam, Bam, and bar. Is that what you got? Let's do another example, but in this case, we won't define the foo variable here. We'll define it here. What happens in this case? Let's think like the compiler and figure it out. Our first pass is to define the variables. We have an outer foo and we have an inner foo. Now with both of those variables allocated, let's execute the code in the second pass. Our outer foo, we'll set that to bar. We'll define and then execute a function. And then our first stop inside this function is to go look for a foo variable. Well, we find one right here. Variables in JavaScript have function level scope. And so this is the same scope. So we'll set this variable that was previously undefined. We'll set it to Baz. Inside this if block, we'll set what was Baz to Bam. And we'll console log Bam. Leaving the curly brace, we'll console log Bam again. And then out here, we will console log this foo variable, which is set to bar. So in this case, we got Bam, Bam, and bar. Is that what you got? Let's do it again. But in this case, let's only define this foo variable out here. What happens here? Let's think like the compiler and figure it out. Our first stop is to allocate variables, and we only find one variable that we'll allocate right here. Our next step is to execute the code. So we'll set this foo variable equal to bar. We define our function and then execute it. Inside of our function, we'll go looking for a foo variable that we can set. Now, we don't have any foo variables defined in the current scope, so we're going to reach up into the outer scope. Hey, there's a foo variable. Let's use that one. So what was bar is now set to Baz. Inside of our if block, we'll go looking for a foo variable again, and we'll find this one right here. So what was Baz is now Bam. We'll console log Bam. We'll console log Bam again. And then leaving our function, we will go looking for a foo variable, find this one again, and we'll console log Bam a third time. Is that what you got? Let's do it again, but in this case, we're not going to define any variables. What happens here? Let's think like the compiler and figure it out. Our first task is to allocate variables. We don't have any, so moving on to the second phase, our goal is to execute the code. We start out looking for a foo variable. Is there one defined in the scope? There isn't. Now we might climb up through outer scopes if we have nested functions here in our document, and eventually we'll get to the global scope. We still don't have a foo variable, so JavaScript, being the ever helpful compiler that it is, will define a foo variable there at the global scope. Now that we have that foo variable defined, we will set its value to bar. Perfect. The JavaScript compiler was able to help us out of that jam. The developer has already left, and this code didn't break. Very nice. We'll define a function and then execute it inside of our function. We'll go looking for that foo variable. Is there one in the current scope? There is not. So let's climb up to the outer scope. There's not one here. Eventually, we'll get to that global scope, and we'll find the foo variable that was defined there, and we'll set its value from bar to Baz. Inside of our true block, we'll set from Baz to Bam, and we'll console log Bam and Bam again. Leaving our function, we'll console log out here that foo variable in the global scope, and that one is Bam as well. Bam, Bam, and Bam. Now let's do this. Instead of setting its value to a string, we'll set it to the Bam variable. What happens in this case? In our first pass, we go allocate variables. So we'll go allocate this first variable. In our second pass, we set our content. We execute the content. So this foo variable, we will set its value to bar. we'll define a function and then execute it. Inside of our function, we'll go find a foo variable. Now, there isn't a foo variable defined in this scope, so we'll find this outer foo variable and we'll set what was bar to baz. Inside this block, we'll try to set our foo variable to our bam variable. So let's go look for a bam variable. There isn't one in this scope. There isn't one in the outer scope. As we climb up even to the global scope, there isn't one there either. Now, our goal is to read the value of a variable, and there is no variable to read, so we get a reference error. Bam is not defined. Now that's weird. When we tried to set a variable, it just worked. When we tried to read a variable that wasn't set, it failed. Well, that's kind of weird. Thinking like the compiler, we can understand why. JavaScript can set variables when they don't exist because it can just kind of help and correct that. But trying to read a variable that doesn't exist, there's no value there to read, and so it has to error. Now, maybe that's one of the bugs Brendan wanted to fix. Maybe we could have automatically allocated a variable, but yeah, that's different. So we get a reference error. Bam is not defined, and our program crashes. Now, let's define that foo variable equal to bam. But in this case, let's switch from var to let. Let is new in ES6, ES 2015, and it allows us to make curly brace scoped variables rather than function scoped variables. So what happens in this code? Let's think like the compiler and figure it out. Our first stop is to allocate variables. We have an outer foo and an inner foo, and we've allocated those variables. Perfect. Next pass is to execute the code. So we'll set our outer foo to bar. We'll define our function and then execute it. Inside of our function, we want to go look for a foo variable. Now, because this is a let, it's curly brace scoped, and so this isn't in scope. So we don't have a foo variable in our current scope. We do have a foo variable in our outer scope. So what was bar, we will now set to baz. Inside of our curly braces, we will define this foo variable as bam. So our inner foo variable is bam. We'll console log bam. And now leaving this curly brace, this foo variable disappears. So we're looking for a foo variable to output. There's none in our current scope. We find this outer foo variable, so we will console log baz. That's what we set right here. Leaving our function, we will now console log foo, and we have baz right here. And so we console log bam, and then baz, and then baz. Is that what you got? Now, what if we comment out this outer foo variable? Now what happens? Let's think like the compiler and figure it out. Our first task is to allocate variables. Okay, so we've got this foo variable right here. Our next task is to execute. We define and then execute this function. So we go looking for this foo variable. We don't find it here. We don't find it in our outer scope. And so JavaScript automatically corrects that and creates a global foo variable. Now we'll set its value to baz. Inside this curly brace, we'll define our inner foo variable, set it to bam, and then console log bam. With the end of the curly brace, we now have our foo variable that we're looking for. We'll find that global foo variable and we'll console log baz. And then leaving our function, we go look for a foo variable. We find that global variable again, and we console log baz again. Wait a minute. This variable that we defined right here is now available out here. Yeah, our variable leaked. JavaScript helped us by automatically creating that variable, and it did so in the global scope. So yeah, we were able to get access to a variable that shouldn't have existed because we didn't define this foo variable. Oops. So we get bam, baz, baz. Is that what you got? Let's do it again, but in this case, we're going to define that foo variable. What happens here? Let's think like the compiler and figure it out. Our first pass, we allocate the outer foo and the inner foo. And in our second pass, we'll execute it. We define and then execute our function. We'll set our foo to baz. Inside the curly brace, we now have an inner foo. It's a let, so it's curly brace scope. So we'll set that to bam, and we'll console log bam. Now out here, we're looking for a foo variable. We'll find this foo variable, and so we'll console log baz. And then out here, we're looking for a foo variable. We don't find one in the current scope. It's commented out. We don't find one in the global scope. And so here we get a reference error. Foo is not defined, and our program crashes. Is that what you got? Yes, by defining this foo variable, we no longer leaked that variable into the global scope. That's perfect. Now, in our previous example, where we didn't define that and it did leak into the global scope, now what if it was called I? Now, what if I had an I variable and you had an I variable? Then we'd be using the same variable and it would be really easy to conflict. By defining our variable, we got a runtime error out here. So our variable was not available outside of our scope, and we didn't get that conflict. That's perfect. Now let's flip from let to const. Const, like let, is curly brace scoped, and it also doesn't have a value that can be changed. What happens in this case? Let's think like the compiler and figure it out. Our first step is to allocate variables. So we'll find our outer foo and our inner foo. Our next step is to execute the code. We'll set our outer foo to bar. We'll define a function and then execute it. Here inside, we'll look for a foo variable, and this const variable isn't available. It's inside the curly braces. So we'll go looking in our current scope. We don't find one. In our outer scope, we have this foo variable. So what was bar, we will set to baz. Well, kind of. It's a constant. We can't set it. So we get a type error, assignment to a constant variable. Now that's perfect. It worked exactly as expected. Now, what if we're transpiling our code into ES5? Now, if that's the case, we don't have const. The way the Babel compiler works is that it will flip const to var. So if you're changing your Babel config to not transpile to ES5 anymore, but to stay with ES6, and suddenly all of your const things start exploding, it's not that your Babel config was broken. It's that your code was actually a var under the hood, so you were reassigning a constant variable. Yes, you need to go fix your code, and once you do, then all is fine. But if you suddenly switch your Babel config and you find you get these type error assignment to a constant variable errors, it isn't the Babel configuration that has caused them. So that was really cool to be able to look through places where we can define and not define variables and the impact of how this works. As we look at the two-phase compiler, it's really obvious now that we think about it why variables behave in this way. JavaScript is trying to help us recover as much as it possibly can. And well, sometimes the behavior is a little weird, but thinking like the compiler worked out really well. Next, let's take a look at this. Now this, I love this definition. This is the thing to the left of the dot. As you grab these slides from robrich.org, click through to these blue links to read or watch more about this definition. Now I grant it is a smidge simplistic, but I find it to be really helpful. The thing to the left of the dot. So I have this code where I want to console log this.name. Now let's take a look at what this might be in this circumstance. Now I have this speak function. I could have defined it inline in both of my objects, but I just have it out here just so that I can reference it more easily. In ES6, I could also leave off the duplicated content. But I have this speak function. I've attached it to two objects, and I also use it outside of this as well. So I'm going to create a name inside the current scope, and then I'll speak. So when I get inside here, what is this? What's the thing to the left of the dot right here? Well, it's the global object. So I get name here. So the first time I call speak right here, I'll get ninja. Now let's do obj1.speak. What's the thing to the left of the dot? It's obj1. So when I say obj1.speak, I get in here, and now it is doctor. Obj2.speak, I get Skywalker. Great. Ninja, Doctor, Skywalker. Let's do it again. Now, in this case, JavaScript is great at being able to use functions as first-class citizens. So let's take obj1.speak and assign it to a variable. Now, in this case, when we do this, the thing to the left of the dot in this case is obj1, so we'll get doctor. But here, the thing to the left of the dot is, well, the global object. So right now, we get nothing. Now, I'm presuming that's something else defined name. Otherwise, we would get a type error here. But when we say obj1.speak, we go reach for this dot name, and we're not inside the obj1 anymore. We've taken that out. There's nothing to the left of the dot here. Well, that was a little weird, but thinking through it, we can understand why this was set incorrectly in this case. I have this other mechanism here. Now I'm going to go get the element by ID, the button, and I'm going to add an event listener, a click event listener, to call this speak function. So when the button gets clicked, what is the thing to the left of the dot? Well, here, the thing to the left of the dot is this button. So when I do this, I'll get the button. I selected it by ID, so I know that the ID is defined. Yeah, the thing to the left of the dot is the button, and that is the this that gets applied to this function. That's great. Now I want to upgrade this code a little bit. Instead of calling this dot name right away, I want to do a set timeout, so I'll show that in 100 milliseconds. What happens here? Now I'll define a global ninja name and I'll call speak. So when I come in here, this set timeout creates a new scope. So in 100 milliseconds, when I call this dot name, this is actually run in the global scope. So the first time through, I get ninja right here. But when I call obj1.speak, it will set a new context. And now I also get ninja here. Well, that was unexpected. I really want this to be ninja and doctor. Let's see if we can control this. Now, here's a mechanism where we can control this with call. Now, call, we can pass in what we want this to be. We could optionally pass in arguments that we want to this function as well. So let's do this. We have obj1.speak. The thing to the left of the dot is obj1. So we're going to get doctor in this case. Now, I haven't defined the speak variable for obj2, so I'm going to say obj1.speak, I'm referencing that function, .call, and let's pass in, override what we want this to be. So we're going to create this new envelope where obj2 is the this. And now when we call this, here's obj2.name, and we'll get Skywalker. Perfect. We were able to control this with call. So let's come back to our example and let's say .call this. Now in our original function, we go reach out, we define a function here, we .call with this, and so we'll get ninja. When we do obj1, we'll also get doctor. Everything is working correctly, except for this executes immediately. It doesn't wait 100 milliseconds. So it'll define this function and then call it, returning the results of the call, which is undefined. And in 100 milliseconds, it will do undefined. It output the name right away. So call isn't an ideal scenario in this case, but we can see how it did get us the right answer. That's cool. Let's upgrade a little bit and take a look at bind. Now, this isn't the syntax for bind, but this helps us understand a little bit how bind works. Now, let's say given a function and a this, we can create a new function. We'll return that new function. And whenever you call that new function, we will call that original function .call and pass in the this. So now if I call obj2.speak, I have this new function that I can call whenever I'm ready that will correctly apply that this envelope. Now let's take a look at the actual syntax. Here's obj1.speak.bind obj2. It's going to return a new toSpeak function that already has this bound into it inside that envelope. So calling it here, the thing to the left of the dot is doctor, and we get that correctly. When we override this, we've created that envelope. So we've overridden the thing to the left of the dot. And now when we call obj2.speak, we get Skywalker. Perfect. So let's come back to, so we may have code like this. You may see this at the top of your React functions where it says obj2.speak.bind obj2 and sets that to obj2.speak. What is it doing in this case? Well, what it's trying to do is override and specifically set the this envelope inside of all of the functions, so that if we call them from various places, various buttons outside of the object, then we won't override the this with whatever button was clicking that button. Now that's cool. Now we get consistent mechanisms. So let's use .bind and see if that fixes our problem. Well, when we start out, we'll set our global thing, we'll speak, it will set timeout. This creates a new function, but we've overridden it with the this that applies right now. And in 100 milliseconds, we'll call that function and we'll get Ninja. obj1.speak, the this coming in here is obj1. So we'll override this, and when it launches, we correctly get doctor. Excellent. So in this case, .bind was the correct solution in being able to get our content into place. Well, there's one more mechanism where we can override this, an arrow function. Now, the cool part about arrow functions is they define this at the point where they're created. So it's much like saying .bind this straight away as we define it. So I've defined this function, and now whenever I call it, I get the this that was bound when this function was created. So let's take a look at it here. I want this speak function, and I'll define it with an arrow function. What happens here? Well, as this speak function gets defined, this gets bound as a to the global object. So name speak, we get Ninja. obj1.speak, we also get Ninja. It's bound to the global object, not to the current object. obj2.speak. So let's use our trick of saying, well, I'm going to say obj2.speak.bind obj2. Well, this creates an envelope with the this bound, and then this one will put that envelope inside of another envelope. As we open the outer envelope, we have a this bound to it. As we open the inner envelope, we already have the global this set. We can't override that. So yeah, in this case, we get Ninja all the way through. Arrow functions are great at reducing the keystrokes, but they also bind this at the point where they're created. If that's not what you want, then just flipping all of the functions to arrow functions is not going to give you the behavior that you expect. So let's try that. Let's create an arrow function here. We know that it's going to capture the current scope. And so let's see if we can do that to better define it. Now, I'm very specifically not using an arrow function for this outer speak. We know that that won't behave as expected, but let's use an arrow function here in this inner function in our set timeout. Now we'll call obj1.speak. Now, coming in here, obj1 is the this. We'll use an arrow function to capture that obj1. And when this new scope happens, obj1 is already set and we get the correct answer, doctor. Perfect. Now we use this inner function to be able to capture the this, to be able to correctly use it inside of this set timeout. That's perfect. But we didn't use it in the outer function because that would have overridden it and made sure that we only got the global this. Yeah, we probably need a comment to describe that. Somebody's going to say, well, I'm just going to flip this to function, or I'm just going to flip this to an arrow function, because then they'll be consistent. But we intentionally chose a non-arrow function and then an arrow function to be able to get the behavior that we expected. We saw how we could override this with call and bind and arrow functions. And we saw how once we overrid it, we couldn't override it a second time. Now that's really cool. We got to understand some of how these things work and really start to make that weird a little bit less weird, more clear. Let's take a look at the event loop. Now, the event loop is really excellent. I love this website where it just talks about how we can view the content inside of our function. This video is great as the author explains how it works. Now, if we run this, it will run the current content. And then as we have content that is waiting for some external resource, it'll come here into this web API section, or the things waiting for external functions. Now, once they're done, they'll come back here into the callback queue. And then whenever the call stack is done, it will take the callback queue and empty it into place. So let's take a look at this code right here. Now, I've got this code to do some interesting things. It's kind of similar to that great JavaScript trivia question about what happens when you count up to 10 and then rig up a button. Yeah, as we're counting, each set timeout will come in here until the timeout is done. And you notice how they're starting to back up in the callback queue. Now, this won't pull anything off of the callback queue until it finishes this call stack. So it's going to need to finish counting to 10 before it starts executing any of these. So, of course, what is the current count once these things start executing? Well, it will be 10. Now it's starting to pull things off the callback queue and setting timeout and then showing them. We can see how once it purges the call stack, it will pull the next thing off of the queue and start to execute it. We have these three mechanisms: the call stack that will run continuously, the callback queue that will get pulled out once it's done, and this content that is just waiting for external resources. So when we say wait a millisecond, wait 1 second, it may be 1 second, it may be a little longer if the call stack is busy doing something else. So that was really cool. When we take a look at these pieces, we have the GUI thread executing on this call stack. We have the callback queue, things waiting to go. And we have these web APIs, these closures, these things waiting on external resources. When these are done, they'll get in the callback queue. And when the stack is done, then the callback queue will come into place. As you grab these slides from robrich.org, click through to these links to read or watch more. Now, when we take a look at the node event loop, we can think of it like this. Now, this is definitely the logical interpretation, not the physical interpretation, but each of the requests have their own stack of stack, callback queue, and external resources. And the node process just kind of goes through and pushes each one to the next step. If the callback queue is empty, it will grab the next thing or if the stack is empty, it'll grab the next thing off the callback queue and execute that. And then it'll come back around. So what if this thread is counting from 1 to 1 billion? Well, then all of these threads are waiting. JavaScript is single threaded. So it might be helpful to yield the thread maybe every 1,000 and let it do a loop and then come back and continue counting. That's a good way to be a good net citizen. So we might see code like this: set timeout of 0. Why would we wait 0 milliseconds? What we're doing is we're yielding the threads so that other processes can run, and then we'll continue on. We could also say await process.nextTick. And in fact, in some modern JavaScript implementations, we don't even need to pass in this empty function. We can just say await process.nextTick, and now we've yielded the GUI thread, and the process can go handle all those other requests and then continue on. That's perfect. Now let's take a look at async and await. Async and await is a really elegant mechanism in JavaScript, clearly stolen, inspired by C#. In C#, we have the task parallel library that async and await is built on top of. Inside of Node, we use that identical syntax to be able to build up these state trees that are based on promises and generators, as opposed to being based on the task parallel library. Now, this is really cool. It's a resumable state machine. So what was this kind of big promise chain of .then, .catch? Now we can turn into async and await code, where we can now use try and catch again, and we can start to think about it synchronously. Now, this is asynchronous code, but it kind of feels synchronous, and we can kind of reason about it in a synchronous way. We'll put an async designation on the top of our function, and then we will await them to be able to get the results in turn, marking this as an async function as well. So do we need to wait until we do a big bang refactor to take advantage of async and await? No, async and await is built on top of promises and generators. So, well, what happens if we have this async function and we don't await it? What is res? Well, res is a promise. Hey, we know how to handle promises. We can dot then the promise. So let's imagine that we have this new function that we want to put inside of our legacy code. Oh, that's fine. We'll just dot then our async function, and it works just fine. Let's take a look at the other example. Now, how would we await a promise-based code? Do we need to wait for the Big Bang refactor to be able to call into our legacy code? Nope, we've got this new promise. And what is res? Well, res is a promise. We know that we can await promises, so we can just await that promise-based code. Do we need to wait until we refactor everything to be able to use async and await? Nope, we can use it right away. Async and await. The interop with promises is really, really elegant. We can await a promise and we can dot then an async method. It's just built in. So how would we do things in parallel? Well, the cool part is we've seen that JavaScript is single threaded, so it's not technically going to do it in parallel. Rather, it'll stick both of them into the callback queue or the waiting queue, the API queue. But let's do that. We have some long running task and we're going to call it, but we're not going to await it. So now that we've got our 3 promises, we do have a mechanism where we can await 3 promises and get 3 results. So we'll say promise.all, pass in an array of those 3 promises, and now we have our 3 results. Instead of waiting until call this library finished before we launch that library, we did all 3 of them at the same time. So if each one took a second, we only waited a second. We didn't wait 3 seconds. That's perfect. We can use this mechanism of async and await and promises interop to be able to do some really cool things like this. Now, we may need to document that we didn't await this just so that a helpful developer doesn't come behind us and put in all of the awaits there. But yeah, that worked out perfectly. JavaScript, not bad for a 10-day project 25 years ago. I think Brendan Ike did a pretty awesome job. I'm really excited that we've kind of been able to disambiguate JavaScript and understand the details of what makes it weird and maybe make it a little bit less weird. The slides for this talk are already available on robrich.org. And if you're watching this video later, hit me up on Twitter at rob_rich and let's continue the conversation. For those of you who are here live in the event in Porto, what are your questions? What are your thoughts? What things should I include when I do this talk next?
Thank you very much, Rob. Thank you very much for joining us here in the Porto conference. We have a question for you, actually, from Francisco. Is it okay, Rob?
Definitely.
Nice. So Francisco is asking, hey, a little bit off topic, but what is the best way to use ref inside a loop in React?
Ooh, what is the best way to do REST inside of a loop? Now, in that case, you're probably going to want to await that REST call. And so much like we did our mechanism of crafting promises, we might want to do a very similar technique as we did here. So loop through your loop, doing all of the REST calls. You'll collect all of the promises, and then you can await all of the promises together. Now that assumes that you don't need the results of the previous call for the next call, but that's probably the fastest way to get through it. Call all your REST things in a loop, collect all those promises. You might even take all of your content and do a loop.map to be able to collect the array of promises, set that array of promises inside of a promise.all, and you'll be able to get all of the results. That's a great example of doing many things in parallel. Great question, Francisco.
Thank you very much, Rob. So I really want to, if no one has more questions, we will terminate here. Guys, feel free to ask questions. It's almost 1 here in Porto, so probably people are rushing up to go and have lunch. Rob. Guys, if you want to contact Rob directly, please, you have here his contacts. Go to his Twitter official page. I'm pretty sure that Rob will be very happy and glad to answer to some of your questions if you have them, even if we are a little bit off topic like Francisco did. Rob, I want to thank you in the name of Porto. It was such a pleasure. You are such influence guy and a great mind. And for
Thank
us,
you.
for the conference, I'm pretty sure that everyone will agree with me that is watching. Thank you very much. It was a pleasure to end the final day of talks with you. To everyone,
most definitely. Thanks for inviting me to join.
Yes, I hope we can see you also next year if we go physically. It will be
yes, it would be great to be back in person.
To everyone who are still going to workshop, the last workshops that we have in this afternoon, they will start at 2 p.m. So be here on time because, you know, we start on time, as you already know. Thank you, guys. I hope you are enjoying. Thank you, Rob. Have a nice weekend. And for the rest of you all, we see you at 2 for the final workshops.